In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Before my lecture, I used to read a Quranic verse, Qala Rabbi Shrah li Sadri wa Yassir li Amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi Zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi Zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, today I'm going to discuss my lecture number 3, Light FCC Gasoline Extractions and Sweetening Unit, Fluidized Catalytic Cracking, Governing a Pathway, Delivering on Commitment, Differentiated Performance, Enabling Profit Optimization, Process lecture number 3. Okay. Light FCC Gasoline Extraction and Sweetening Unit, lecture number 3, Major Equipment, Items and their Purpose and Functions. Okay, key takeaway points from lecture number 3, FCC Gasoline Extraction and Sweetening Unit. Okay, now today we are going to discuss first extractor, reactor, oxidizers, wash naphtha settler, Disulfide Separator, vent tank, Disulfide sand filter, Merox Caustic injection nozzle, air mixer, special checkpoints. Okay. Before discussing the equipment functions, we'll run a simulation model and understand how the extractor, reactor, oxidizers, disulfide separators are functioning. Okay. First here, they start up the unit. So unit will start. Meter circulation. Okay. We have just run the simulation model. On my next lecture, we will discuss each stream and their functionality. Okay. Key takeaway points number 1, extractor unit. The extractor is vertical vessels consisting of 8 trays depending on the feed, specially designed or perforated trays. Each tray consists of caustic inlet reservoir with the inlet where separated this reservoir from the central mixing region. The central section is the mixing region of each tray and contains perforations to allow the upflowing gasoline to contact the cross-flowing caustic. The caustic mixing with the gasoline disengage as it is carried upward and overflow the outlet weirs. Collecting in the caustic outlet reservoir, a downcomer pipe transfers the caustic to the next tray inlet reservoir by gravity flow. Since the caustic flow rate is a low rate relatively to the gasoline flow, it is very important that both inlet and outlet weirs are leveled. Also, no caustic leakage can be tolerated at any point in the tray. The tray should be entirely sealed except for man-made. These are sealed with neoprenes or rubber gaskets. The inlet and the outlet reservoir should be leak tested and contains no leaks. Even the tiniest leaks will serve to reduce the extraction's efficiency and capacity by upsetting the carefully designed hydraulics. The gasoline inlet or feed tray contains no holes in the mixing sections but instead contains an inlet distributor designed with holes oriented or downward to distribute gasoline over the bottom of the feed trays. The size and number of holes should be verified. The end must be capped. The bottom of the extractor column serves as a caustic surge reservoir for entire system. It is fitted with level glass and level indicator with a low and high level alarm. Okay. Next is a reactor. Okay. Reactor configuration. The fixed bed reactor is a vertical vessel designed to contain the charcoal bed upon which Merox catalyst is impregnated. Internal equipment is limited to an upper inlet distributor, lower side outlet collector, a bottom dead screen, and a drain port. Balancing line screen flow is downward through the bed. The inlet distributor is designed to provide a uniform lateral flow distributions over the reactor cross-section. The distributor holes should be oriented upward. The holes in the inlet distributor should be protected from plugging during the charcoal loading, wrapping the distributor with canvas or plastic covering. The outlet collector and the vessel strains pipes are specially constructed stainless steel slotted screens of a proprietarily designed manufacturer by the Johnson Screens. The screen slot width is 0.25 meters or 0.01 inch. The drain port, a balancing line screen, is normally a much smaller version of the small type of screen. These slots should be closely inspected before commissioning to ensure that any damage serving to open these slots is repaired. Anytime charcoal is unloaded, these screens should be cleaned with wire mesh since charcoal finds collecting here and can often lead to screen plugging problems. The most recent Merox reactor designs specify that the bottom head of the reactor be filled with concrete. The concrete should be carefully screened for level up between the supporting ring. Okay, oxidizer. The oxidizer is a vertical vessel designed as a mixtures to conduct a rich caustic from the bottom of the extractor, containing a Merox catalyst and a sodium mercaptides with air for regeneration. Since this vessel contains mixed vapors, liquid phase packing is provided in the form of a 40 millimeter diameters of carbon ration rings. Carbon composition is used because it is inert to the strong acoustic and severe oxidizing environment encountered. Because these rings are subject to breakage, the loading should be done with the vessels filled with water. A conscious is added that the vessel should be completely full of rings, flush with the top mainway, otherwise ring alterations will occur as a result of the abrasive contact caused by the substance shifting action. Inlet distributor is provided consisting of a perforated pipe enclosed by a slotted sleeves. The slot in the sleeves point downward with the holes in the pipe are oriented upward. This arrangement is designed to provide maximum mixing. Should the inner pipe ever plug or require a modification, it can be removed without having to unload the rashing rings. And outlet connections should be protected by bar gratings, which usually consist of a 6 millimeter bar welded across the nozzle to prevent any rashing rings migration. The vessel drain is protected by a broken ring strap consisting of a slotted pipe to exclude ring fragments. The mixtures of the rich caustic with caustic catalyst, air, and circulating wash naphtha passes through the oxidizer from bottom to top. The oxidizer product is routed to the disulfide separator. Okay. Wash naphtha settler tank. The wash naphtha settler is a horizontal vessel designed to promote gravity separation of aqueous caustic solution from the wash naphtha. An inlet distributor is provided to avoid excess inlet turbulence and promote an even flow distribution through the vessel. It consists of single pipe arranged vertical through nearly the full width of the vessel's diameter, with one full-length slot facing the nearest head of the vessel. Regenerated caustic solution with wash naphtha is sent to wash naphtha settler tank by caustic circulation pump. The regenerated caustic is returned from the bottom of the wash naphtha settler to extractor unit. Wash naphtha exit at the top of the wash naphtha settler is split into two streams. One stream is circulating back to the suction side of the caustic circulation pump. The other one is routed a level control to the oxidizer. Okay, disulfide separator. The disulfide separator is a horizontal settler vessel with a small air disengaging stack at the end. The inlet distributor enters at the midpoint of the stack. It is slotted atop and bottom to add both disengaging and distribution. The excess air flows upward into the packed area. The packing consists of 25 mm 1-inch diameter carbon steel arraching ring. These rings are susceptible to corrosion, especially during a period of sustained operation at high oxygen content in the wet gas. These rings should be inspected regularly since they provide a secondary safety function, that is a flame arresting as well as acting as a demister. The liquid passes downward into the main vessel or horizontal section of the separator. It encounters a second packed zone that is 1200 mm or 4 feet in length. This zone is packed with 4x8 mesh anthracite coal which acts as a coalescer to aid in the separation of the disulfide oil from the regenerated caustic. The coal retaining screens are 9x9 mesh with 1/6 mm 0.063 inch diameter wire supported by standard deck type grating. It is important that the angular space between these screens and the vessel's wall, along with any space between screen section, be carefully sealed with sacral, otherwise coal leak may result. Okay, vent tank. This small vertical atmospheric vent tank is provided to separate any liquid carryover from the vent gas exit the disulfide separator during startup of periods of unsteady operation. Liquid carryover is not normally expected to occur because of orders. The preferred disposal of vent gas is to incinerations rather than to atmosphere. The packed zone is provided to coalesce any liquid and provide a safety function as a flame arrest. The packing consists of 25 mm of 1-inch diameter carbon steel ring which are subject to same loading and maintenance as a detail for the disulfide separator stack. The bottom drain is open to sphere but sealed by means of hydraulic overflow seal. Thus, for startup, the vent port must initially be filled with water in order to provide a seal. Okay. My next topic is disulfide sand filter. Okay, disulfide sand filter, next equipment. When the disulfide oil goes to any downstream processing to a FCC unit, etc., a sand filter is usually provided to coalesce any entrained caustic or wash naphtha solution. A sand filter may be desirable even if the product simply goes to storage. The sand bed of the disulfide sand filter consists of a specified depth of 8 to 16 mesh quartz or silica sands. The sand bed is supported on a special Johnson screen. Property designs a steel grate with 0.6 mm or 0.025 inches opening. Disulfide oil enters at the top of the vessel. through a slotted distributor, passes downward through the sand bed through the sport grate, and make a turn before exit from the side of the vessels. Below the sand sport grate, the disulfide oil outlet is protected by special Cordell's baffle. Okay, caustic injection nozzles. The type of nozzle used for caustic injection in the mining unit is specially designed a caustic atomizing nozzle. It is used to disperse the low caustic flow rates required for the manic versions of the fixed bed sweetening process. It is inserted in a pipe elbow so that the caustic spray is directed in the same direction as the gasoline flow. The nozzle inlet is stainless steel with very tiny restrictions orifice. Often it also contains a helical-shaped rotating internal element. The function of these parts is to create a full cone spray pattern. Thus, the liquid clearance are of the necessity very small and nozzle will plug up easily. For this reason, it is important that the caustic injection pipe be flushed extensively before startup to remove all dirt. Since plugging is likely, the nozzle is removable without shutting down a gasoline flow. A in-pipe system is used. A packing gland is provided to seal the annular space between inner and outer pipes. To remove the inner pipe and nozzle, the packing is loosened tightly, allow the inner pipe to slip back until the inner nozzle clears the shut-off valves. The complete removal of the inner pipe and nozzle for clearance. Okay, air mixer. This is a specific piece of equipment common to all fixed bed sweetening unit. It consists of central mixing chambers in which gasoline and air meets from opposite directions. The common exit for gasoline containing dissolved air is perpendicular to the inlet. A snetted stainless steel filter cylinder is provided to disperse the air. If the air lines contains any dirt, this filter will become plugged. Okay, special check valve. The purpose of this piece of equipment is to prevent a backflow of either a caustic extraction unit or gasoline sweetening unit to the source of air. It is installed directly on the air line just upstream of the injection point into either rich caustic or the sour hydrocarbon steam. The feature of this check valve include its low cracking requirement, that is 0.14 to 0.28 kg per meter cube or 2 to 4 psig, and positive spring loaded closing actions. Although no check valve is 100% fail safe, these valves have proven themselves quite reliable over the years. The valve must be installed in vertical positions, and it is recommended to use a stainless steel tubing on its inlet side in order to prevent extended pipe threads either hindering the operation of the damaging the valve internals. Conclusion. What we discussed today: first, extractor, reactor, oxidizer, naphtha circular tank, separator, sand filter. My next topic will be a preparation of initial startup of light abscess gasoline extraction and switching unit. These are a few references. Okay. Together, everyone achieve more. Please do not hesitate to send me your feedback, comments, t.masood.dr@path.edu. You may send me your input through WhatsApp number. I have provided my WhatsApp number as well. Thank you very much for your precious time.